We're back and better than ever. We're in 9.4 where we're going to be naming and writing the formulas for acids and bases. Now, in fact, we're actually not going to show you how to name bases. You already know how to do that, so I'm going to cross that out. Bases are simply ionic compounds, and so you've actually already named bases back in 9.2. In this section 9.4, where you're naming acids, you simply have to remember a couple rules. You change your eights to icks. You change your ites to us's. And if it's an IDE ending, you turn it into hydroblankic acid. Okay? Now, what does all that mean? Well, let's go ahead and walk through a few of these. I think you'll pick up on it pretty quick. You guys are all very intelligent people. And so you change your ate to ick, your ite to us's. You keep your pers and your hypos, and we'll show you that, and IDEs turn into hydroblankic acid. So here we go. What do we mean by you change your eights to icks? Well, in this case, let me back up just for a second. You name your acids based on the anion. All of the cations are going to be hydrogen. That's what makes an acid an acid. The cation is hydrogen. So, in fact, in reality, it's not really a cation. These are actually molecular compounds, but we're not going to get into some of those details. But realize that they all contain hydrogen, leading hydrogen, so the only thing that you need to do is worry about what anion is attached to it. All right? So, in this case, ClO3 is the chlorate ion. So, therefore, when you name this acid, you simply change your ate to ick. Chlorate becomes chloric acid. That's it. Change your ate to ick, and then you call it an acid. The chlorate ion forms chloric acid. Now, ClO2 is the chlorite ion. Chlorite has one less oxygen. You change your ite to an OUS ending. So chlorite turns into chlorus acid. Chlorus acid. Now you also will keep any prefixes like pers and hypos. For example, up here, going up above now, oops. ClO4 is the perchlorate ion. So perchlorate forms perchloric acid. Change your ate to ick. Perchlorate, perchloric acid. Chlorate, chloric acid. Chlorite, chlorous acid. Down here, hypochlorite. Hypochlorite forms hypochlorous acid. So you keep your pers and your hypos. And scrolling down, here you have a monatomic anion. It ends in IDE, so chloride becomes hydrochloric acid. Hydroblankic acid, chloride becomes hydrochloric acid. Okay, let's try a couple more. HNO3. You know it's an acid because it has a leading hydrogen. So then you just have to look to the anion. NO3 is the nitrate ion. Therefore, nitrate turns into nitric acid. Down below it, again, you have your leading hydrogen, so you know it's an acid. NO2 is nitrite, therefore we call this nitrous acid. Nitrous acid. Over here, you have a leading hydrogen. In fact, you have two of them. The reason why you have two of them is because you have a -2 charge here with a sulfate, so you're going to need two hydrogens to balance that. Of course, we leave that 2- off there. But it's still named with the anion. SO4 is sulfate. Therefore, we call this sulfuric acid. Now, if you said sulfic acid, I would say, well, yeah, that's what the name would imply, but we actually pronounce it sulfuric acid. SO3 is sulfite, therefore we would call this sulfurous acid. And lastly here we have H2S. We have a monatomic anion, that's the sulfide ion. Ides turn into hydroblankic acid, so sulfide is going to be hydrosulfuric acid. Hydrosulfuric acid. Alright, so the simple rules are you change your ates to ic, ites to us, ides to hydroblankic acid. In the next podcast, we're going to take names of acids and try to reform their formulas. We'll see you next time.